My partner here is Miguel Elias Robles, and my name is Thomas B. Ricker. We hope to entertain you for the next 45 minutes plus Q&A. Okay, let's start with a small overview of the lecture. We'll just point out some basics. Sometimes we won't even go in depth, just point out what you should check to understand the further topics. And then we'll start with WarTracking itself. It's just some history, what was in the past, what were interests on satellites in the past, what was interesting. Then present, which is more or less, we said 1985 to now, just to make a difference to the past. And then we'll consider what will be the future of satellite communications, what is interesting, what can we expect. And then we'll go on to hands-on WarTracking. That's more the practical part, looking at what you can do actually, what you can listen to, that's passive, and where you can actively use satellites legally and illegally. That's the next point, legalese. What are legal implications of passive or active use? And then we'll end up with the Q&A session. Okay, so let's start with the basics. What is a satellite? A satellite is an object circling around another object, as opposed to objects that leave the circle around the object. That would be like Mars Explorer. That's not a satellite that left Earth orbit. Orbit is the path around the planet in that case. A geostationary orbit is a special case. The basic point is it's a very interesting orbit because you can use it for communication satellite. If you look at a satellite from Earth, it appears as if the satellite wouldn't move at all, because it's more or less moving around the Earth in the same speed, the same angular velocity as Earth turns. So every 24 hours it circles around once, so it seems to never move. Okay, ecliptic, another element. We'll just speed it up a bit. Keplerian elements is a thing you will be needing afterwards, after this lecture. That's the sum of all relevant variables of an orbit of, for example, a satellite, to know where it is. You can feed those Keplerian elements into a specialized software, and then it will tell you that the satellite is exactly over there. And then you know where to point the antenna or where to look. Some satellites can be seen from Earth. The most famous is the Moon, of course. Payload. Payload is, that's what we are basically interested in. That's the part of the satellite that is active, where, for example, the TV program is relayed from orbit back to you, to your home, to your satellite dish. Frequency bands used for satellite communications are, for example, the most used TV band is around 10 to 12 gigahertz, that's the Q band. And there's also C band around 4 to 5 gigahertz, more or less. You can find all those informations easily, for example, in Wikipedia, so it is not necessary to cover them here and now more. The transponder is a thing we should mention too. It's, well, the logic element of the beam coming down from a satellite, for example. It's a part, a frequency band, where a special information is contained. For example, a TV program, or with DVB, a digital video broadcasting or digital data broadcasting. It's the complete multiplex containing all TV, radio, and additional data. Okay, so much for that little basic introduction. And now we're going on to in medias res to go to the past. That will be covered by my colleague.
Well, the first satellite, it's Sputnik. It was launched at September 1957. It was nothing else than a radio transmitter in 20 and 40 megahertz. It's really low in frequency. And it was really fast. It had only 6 hours, I think, to take around the whole world. And he only transmitted temperature outside and inside of the satellite and the pressure. Historical, you remember the Americans had a shock. Well, they said, well, they launched a rocket and they had the satellite on the in orbit, and we can't, and why it doesn't. And the important thing in this is they launched the Sputnik with a standard atomic bomb, ACBM rocket. So they show with this satellite that they can arrive with their rockets America, and this was the important thing. I have a little audio recording of the sound of the Sputnik. Oh, sure. This was what you heard, 1957. This was temperature and something like this. So you can, on this frequency, you can hear it with a standard AM radio. So anyone in the Earth, and the moment the satellite overflow you hear this sound and the frequency of 40 and 20 megahertz. So anyone know that the Russians had a satellite above your head. Well, GLONASS. GLONASS was a satellite systems. They use it for reconnaissance, like they can make photos, really sharp photos. They said it was more for weather satellites, but I think no one believed it. The thing is, the last GLONASS satellite, 945, hit the ground and Canadian ground. So they found out they had an atomic reactor in it. So Russians shot satellites with atomic reactors in the space, and they didn't know that the satellite hit the ground. The Canadians called the Russians saying, "We have something from you." USA. Well, the first telecommunication satellite and, well, telecommunication and television satellite was the Telstar. It was something like a ball, nothing bigger than this. It was really unstable, and to make a connection, well, the American president wanted to make a television transmission to France. They had only a half an hour because the satellite overflew the Atlantic, a half an hour, and after this half an hour, it hasn't more. The satellite was anywhere, but not in Atlantic. And the funny thing is, it was really unstable. It was a ball, it making everything, but so this was the first video transmission from USA to France and from France to USA. Not really good. They had problems with NTSC signal. Never the same color. Well, something different, isn't it? NOAA. I think you know more about the NOAA.
Well, the NOAA are satellites, are basically some weather satellites by the NOAA, and they provide, for example, weather pictures and other things. Well, that's just to give some idea what's up there. There are other satellites like the GPS satellites by the US and things like that, and also other countries had their satellites too, military or civil use. For example, well, go on.
Well, the next country was France. France was one of the successors of Russia and USA. They sent the first satellite from Africa, I think. It's nothing special. They only had the satellite only was for to saying we have also a rocket that can reach the space. Japan was after this, after France, taking the first communication satellite for Asia. Well, Americans had the satellites, but they reached Japan, but that doesn't had Japanese programs. Germany had launched with the ESA some satellites, and UK. This is something special. They launched many satellites, but only with well, one of the satellites was launched from a submarine, and because they had the rockets in the submarines, and so it was possible. Present communication satellites. Your turn.
Okay, thank you. This is telecommunication satellites in the beginning of the period we took as past, that's 1985, were basically phone lines and television lines for transatlantic transmissions. For example, many phone calls were dispatched that way, and that was a very interesting period because all that comes were just multiplexed analog signals, so it was really easy to listen to that stuff. That was really interesting. You could find some really interesting information there. This is still true. There are satellites, for example, Arabsat, operating in the C-band, visible from Europe. You can receive it with around 1 meter, 1.20 meter dish with an low noise block amplifier for the C-band. And well, there's a transponder you can tune into, and you'll find there are still plain phone lines there, and you can listen to phone calls, trace them, see who called whom, and there's just plain in-band signaling by DTMF, and you can listen to fax transmissions. So that thing's not dead yet. Another analog communication satellite system that is not so much for video but for phone lines is Inmarsat A. That's still also an analog system. There are the successors Inmarsat B and C. Those are more advanced, but the old system is still in use, and well, you can listen to interesting things there too. Well, then there were, of course, the military and intelligence satellites, also pointed out by my colleague, that was intensified in those years, and there were also interesting transmissions there that could be even seen with just normal home TV equipment. You had just turned the dish a bit around. For example, there was a satellite placed more or less above the Atlantic Ocean, and during the war in Yugoslavia, the US military just booked some transponders there. The US military is famous for outsourcing many things like communications, and the outsourced partner just bought some plain transponder space for TV transmissions, and well, someone accidentally tuned to that transponder and saw things like reconnaissance planes flying around Yugoslavia, observing suspicious places, and it had also some communications there. Well, there are sources for that. It's even covered in books. You can read on about that. We'll place information about where you can find this on the website. The URL will be provided at the end. Okay, so the more interesting things, UFO and fleet.com. UFO is just an acronym for what was it? Sorry, I forgot, but it's the communication system that was basically brought up very shortly before the first Gulf War. The Bush administration, the first Bush administration, had said, well, okay, we need a communication system for our armed forces, for an external mission, for a war now. Well, I think they asked Boeing, okay, you have 2 months, give us satellites in orbit. Well, 10 pieces or so. Just give them. Well, they had no time for real security. It's just plain old bent pipe repeaters. It's just, you can point a directional antenna at the satellite and listen to communications. They are mostly plain narrowband frequency modulation. Well, you could even send narrow frequency modulated signals on the input frequencies. That would certainly work. Later on, a bit more about that. Not. Thanks. Some more. Echelon. Echelon is mostly referred to as being a ground-based system. There are also some satellites in orbit that are quite huge and have quite big possibilities and capabilities. There is information on that. We don't have the time to cover that, but you can visit us later on or look at the site. We will have some information for you there. They have really big things in orbit that have really big ears. Okay, Skynet is just the British version or the Italian version. Well, there are also other military nets, of course. Brits have their own, Italians have their own, Russians have their own, and Skynet is one of those. If I recall correctly, that this one has also some lower frequency, easy to use comms, but that's not so much wide known. Okay, of course, those military satellites have also not so easy to use transponders, but later on a bit more. Okay. companies too. And it could be really interesting to research that topic, but the communication itself between the phone and the satellite is probably more or less safe.
What kind of hardware would you suggest for automated tracking so that you could do some sort of programmable sweep of the sky?
If you want to track not only the geostationary satellites, but satellites that are moving, you'll need an azimuth and elevation rotor. That means an antenna can be turned once around and also from 0 to 90 degrees in the angle. And you can either build it yourself, depends on the size and weight of the antenna. There are azimuth elevation rotors for radio amateur use. That might prove not that expensive, or you can buy commercial ones that would be priced around 1,500 euros, I think, but they are very heavy duty and very good. It's a company called Aegis, if I if I remember correctly.
And about Inmarsat, you talked about Generation A. What about their always-on data terminals, and what kind of cryptography are they using? Have you monitored them at all?
Well, I haven't been playing with Inmarsat myself. I've just read and talked to people about that, and it's just based on my findings, what I was talking to people that have researched Inmarsat.
Thanks.
The other question.
Okay.
You talked about the thing you used and you tried in experiments.
Yeah.
It was like telephone communication or voice communication. Yeah. What is about information communication? Is it able to do kind of data communication, for example, with these amateur satellites, which is free to use?
Yes, certainly. You can use amateur radio satellites for data communication. A very famous example for that is the International Space Station that is carrying some amateur radio payload. Mostly it is in a mode called APRS, that's Amateur Position Reporting System. You can broadcast your position with that system. It is a baud rate of 1,200 baud, more or less. And the uplink is at 145.8 megahertz, and the downlink is on 70 centimeter band. That's somewhere around 430, 440 megahertz. I would have to look it up. There are also other satellites that carry mailboxes. You can use them to relay messages. This was, for example, used for relaying messages between America and Europe for some time. And a thing really to mention is this is no real big bandwidth you can expect, and another thing is you can't use it for purely private communications, and you can't use encryption in amateur radio. So it's not you can play with it and have private conversations between you and someone else encrypting the path. Amateur radio is a mode that is public by definition. Does that answer your question?
Not really. One thing more. Is it possible to make a TCP/IP connection over satellites, over these satellites?
Yes, but it will be very slow. As I pointed out, the data rate is about 1,200 baud, and it is possible to work IP on that.
Thanks.
Have you looked into combining your setup with software radio technology or
With what technology?
software radio technology for demodulating?
Software radio. Well, software radio. Um, broadcasting satellites secure their uplink. Is that the question?
Yeah, and if you may perhaps point out the example of the Falun Gong hack. That happened some years
What
earlier.
example?
I heard that people from Falun Gong were actually able to broadcast over satellites in Asia somewhere.
Yeah. It is, well, as I said, some satellite companies monitor their satellites closely, some not that closely, and that probably was a combination of running a denial of service attack against the satellite plus taking over a transponder. For example, they found an open transponder, or they just jammed or had a stronger signal than the normal signal on that transponder, and simultaneously jammed the control channel so that the satellite broadcaster could not, for example, turn off the transponder. That's a way to work with that. That could be what it was, more or less. But most satellite companies are well equipped for that cases. As I mentioned before, the in-field engineer had a real problem after sending 20 seconds or 30 seconds of video. Okay, there's a question over here.
There are various commercial IP over satellite solutions. I was just wondering whether this data stream was just in the clear or encrypted somehow.
Well, sorry, what was your exact question about that IP? IP broadcasting?
No, there are commercial internet access through satellite offerings.
Yes.
Are these data streams usually encrypted on the link level, or is it just clear IP?
Well, as pointed out in the lecture yesterday, it's mostly plain MAC security. Receiver cards have MAC addresses and mostly work just listening for their own MAC address. You can run them in promiscuous mode. This can be seen illegal in some countries already. Not sure about Germany, don't know. But there are interesting pieces of software that can be run on that. For example, I imagine it would be real fun to run DriftNet on that, just to watch images flowing down from orbit and things like that. Okay, I think we'll leave some minutes for the next lecture to set their computers. And if there are any questions left, please feel free to visit us upstairs on the second floor, and we are at the CA third stand. We'll also provide some internet address where you can visit. At the moment, there are only the slides from the lecture at the moment, but we'll provide some additional information like bibliography and some links to interesting sites just for your entertainment. Okay, so much for that. Thank you very much for your attention. As said, feel free to visit us, and the URL is here. Well, it is a bit small, I have to admit.